Thanks everyone for joining this meeting. Some of the milling machines are reported to be malfunctioning or broken. Let's begin by identifying possible causes. Technical investigator will start.
On my inspection, there may some maintenance have been missing, and there are dry lubrication, possible coolant contamination, and also sign of backlash and unusual spindle noise.
There's already a serious risk. This machine must stay under check-out. No one operates them until we finish a full inspection on the machine. A spindle failure can throw metal fragment at high speed.
On the positive side, this situation is a chance for students to observe the real industrial value, analysis and understand maintenance importance. We can even involve them in the documentation process.
Great. We'll gather data first, such as machine model, age, failure symptoms, and then decide whether to repair or overhaul, or since grade is the status quo.
Now, let's move to safety risk with operation. Safety officer, please continue.
The risk could include tool breakage, sudden axis movement, electrical danger, and emergency stop failure. Anyone near the machine could get seriously injured if it's malfunction badly.
What exact precautions do we implement before any use?
Okay, first, lock out. Second, power disconnection and inspect of backlash. Also, wiring, spindle alignment, and most importantly, only trained personnel allowed. No student until they are certified. Thank you.
Once restored, we should have a training session for student highlighting machine, acoustic prevention and maintenance awareness.
After repairs, we'll conduct a trial run with soft material, document results, calibrate, and sign off safety before activation.
I'm checking the spindle manually. I can feel cycling. That's mean during hearing wear. Also metallic noise when rotation by hand. Looks like rotation hasn't been applied recently.
Also, I see coolant leakage near the wire. That alone is an electrical hazard. I'm applying lockout tech now and the power is going to be fully disconnected.
This is exactly the kind of real-world scenario students must learn from, not just textbook reasoning. We can recommend this as a live test study.
Allow the condition, spindle looseness, coolant leakage, possible bearing failure. We will estimate if replacing spindle assembly is cost effective or if upgrade is needed.
Good. Let's simulate next steps. Let's assume the team has fixed it after 1 week. Now we are checking if it's safe for use.
Okay, we will be testing the spindle with aluminum test, making sure there's no abnormal vibration and have a smooth rotation spindle, backlash are reduced, and lubrication system working.
Excellent. After reactivation, I run a short safety briefing for students focusing on quality, clamping, and respect for machines.
And I recommend monthly preventive maintenance, visual lubrication, alignment checks, and student usage log monitoring.
See, if you analyze, please introduce the student benefits identified. If you plan that this includes our assessments. Good job, everyone.
Kenapa? Kenapa